This video is on 2.3 continuity, so we're going to go through this slideshow. Here's your objective, to be able to determine the continuity at a point, identify a function, and use the intermediate value theorem. Basically, if you can draw the picture without lifting up your pencil, it's a continuous function. This is the most important slide in this PowerPoint. You have to know that these three things are true. You have to show that f of x exists. You have to show that the limit as x approaches c from the left and the right are the same, and therefore the limit exists. And you have to show that those two numbers are the same. Write this down. I will show you an example. So here we go. Use the definition of continuity to determine if it's continuous at these 3 points. So in order to do that, you need to do this. So let's see if we can do two things at once here. We need to show the first thing is f of 1 exists. Well, in this case, you can look at the picture and see that f of 1 is 1. Then we need to show that the limit as x approaches 1 exists. Well, the limit from the left as x approaches 1 is 0. The limit as x approaches 1 from the right is 1. Since these are not equal, the limit as x approaches 1 does not exist, therefore not continuous at x equals 1. You actually have to show these steps. Let's see what happens for f of 2. f of 2 is 2. The limit as x approaches 2, you can see from the left and the right, are both 1. However, the limit as x approaches 2 is not equal to f of 2, therefore not continuous. Now you could write out in words that because f of 2 equals 2 and the limit as x approaches 2 equals 1, the function is not continuous because they are not equal. You don't have to use this. This is therefore, in case you don't know that. But you don't have to use this math terminology, but you have to show what f of x is, what the limit as x approaches this x is, and that they are equal or not. If you look at 3, f of 3 is 2. The limit as x approaches 3 is 2, and therefore the function is continuous at x equals 3. And we also say the function is continuous at x equals 4 because f of 4 is 1. The limit as x approaches 4 is also 1. Even though it's only one-sided, it's still, the limit is still 1. And so the function is continuous at x equals 4. That's the most important part of this presentation. A function is continuous on an interval if and only if it's continuous at every point of the interval. A continuous function is one that is continuous on every point of its domain. This is important. A continuous function need not be continuous on every interval. So let's show you what that means. This is a continuous function. The reason it's a continuous function is because its only place of discontinuity is at x equals 1. And since x equals 1 is not in the domain, it's continuous on every point of its domain. So even though you pick up your pencil when you draw this, the only place you pick up your pencil is where the domain is restricted. So it's still called a continuous function, even though you have to pick up your pencil. Same thing here. The given function is a continuous function because it's continuous at every point of its domain. It's not continuous at x equals -2, but it's also not defined at x equals -2, so that's okay. Okay, these are super important. These are AP Calc questions. So find a value so it's continuous at that thing. Okay, so let me show you what's going on here. Let's first find out what f of 3 is, because we want to know if it's the only place it could be discontinuous is at 3. In order to make it continuous, we have to figure out the value of a. Well, when x is 3, the function's value is 15a, because you plug in 3 for x in the bottom function. 5 times a times 3 is 15a. The limit as x approaches 3 from the left, you plug into the top function, and you get 7, because 3 squared minus 2. The limit as x approaches 3 from the right, you get 15a again. Well, in order for this function to be continuous, these two things must be equal. So we're going to set them equal and solve for A. So 15A equals 7, and A equals 7/15. Okay? Let's look at the second one. Again, we have to find f of 5, and it's only defined in the second equation, so it's 125. The limit as x approaches 5 from the left is 25, 30, a plus 30. The limit as x approaches 5 from the right is 125, because we plug it into the bottom function. So a plus 30 must equal 125 in order for this function to be continuous at x equals 5. And so therefore a must equal 95. Okay? Back to the slideshow. These are just some rules. The sum of two continuous functions is continuous. The difference of continuous function is continuous. If f is continuous at c and g is continuous at f of c, then the composite g of f is continuous at c. Okay, this is a really important theorem, the intermediate value theorem. Basically, they're telling you if this function never has a break or a hole or an asymptote between a and b, then it must cross through every single y value between f of a and f of b. That's what it's saying. So let's see what an example of that problem might look like. Use the intermediate value theorem to show that that continuous function has a 0 in the interval -2 to -1. So they're saying that that graph must cross the x-axis between -2 and -1 because we know it's continuous. We know it's continuous because there's no restrictions on the domain. We kind of know what the graph looks like. So all we have to do is plug in f of -1, and when we do that, we get 1 minus 2 is -1, minus 3 is -4. F of -1 is -4. Then we plug in f of -2. That is 16 minus 8, which is 8, minus 6, which is +2. So since f of -1 is -4, and f of -2 is +2, it must cross through the x-axis because there must be a y value of 0 between the x values of -1 and -2. That's what the intermediate value theorem says. Number 2, try f of 1 and you get 1 minus 7 is -6 plus 3 is -3, and then 0 is +3. So since it goes from negative to positive and it's continuous, it must have a 0 in that interval. All right, so that's the basis of continuity. You need to know the definition by showing that f of c exists, the limit as x approaches c equals, or also exists, and that those two values are equal. That is the most important part of this lesson. If you can understand the intermediate value theorem, that's great too. Try number 3, we'll talk about it in class. How do I stop recording? I never remember that.